It's a pleasure to welcome you today to Ampere's first Software Developer Conference. Today, we're not just gathering as individuals, but as a vibrant community dedicated to exploration, innovation, and the transformative power of technology. My name is Pete Baker, and I work at Ampere running the Customer and Developer Engineering Group. And we represent you, the software developers, the SREs, the DevOps engineers, the people with hands on keyboards, advocating not only for designing the world's best microprocessors, but doing so in a way that provides you the performance and capabilities that you want, but also the ecosystem and ease of use that you need. After over 30 years in the semiconductor and software business, I found that it's the marriage of hardware and software together that propels breakthroughs, be it with multimedia in the 1990s, or laptops with Wi-Fi in the early 2000s, or cell phones becoming smartphones, becoming the lifeblood of everyday living, to more recently the migration to the cloud with new services available every day. Though the notion of a community to create, deliberate, share, and celebrate has been around since ancient times. Historically, the power of community has been a catalyst for progress. In each of these brief examples, it was the community of hardware and software engineers that transformed the outcome. Even reaching back thousands of years, the ancient Greeks would venture out to sea to explore new lands. They had to design and build new ships, improve cartography, and deal with the weather. The notion of the term synago was a gathering where ideas and experiences converged to share, shape, and celebrate that exploration. That same spirit is what gathers us together. My hope today is that you share generously, learn zealously, and leave better prepared for the adventures of the future. And here at Ampere, we like to think of ourselves as adventurers and risk takers. We're a modern semiconductor company. We're reinventing the way CPUs are designed and constructing the first cloud-native processors. So why is a semiconductor company so interested in software development? Well, because we're witnessing a significant transformation in computing. Ampere has embraced an efficient multi-core design philosophy, resulting in a processor architecture that delivers better power efficiency compared to legacy designs and lets us remove various design baggage we've collected along the way. For the many of you who are frequent users of Ampere products, thank you. And for those of you who may be here learning about us for the first time, welcome. As a developer, why might you consider Ampere instances? Well, there are really four distinct advantages. First, we've got a ground-up cloud-native design. We built these based on our experiences with customers working on all kinds of cloud workloads, from web services, data science, machine learning, and AI. Our designs offer high numbers of physical cores to be leveraged by software to scale up and, yes, scale out. Each vCPU in our case is a full CPU. Every core is a real core, and because of that, each instance is more efficient and can do more work and minimize noisy neighbors. This allows for consistent, predictable performance. And all of that translates into a design that offers not only the high efficiency, but also reduces energy consumption and often cost, and allows customers to meet important carbon emission reduction targets. Stay tuned for more on all of that. I'm sure Sean's going to give a great view of this in deeper detail. Though we're not just building a single instance of technology, we're building a robust roadmap to address needs really across the spectrum. So working from the bottom up, starting with the Ultra and Ultra Max entrants, this is the most efficient product family for modern compute environments, from edge to on-premise to the cloud. Though looking ahead, we've recently shared our extended roadmap, including the Ampere 1 family of processors with our custom IP for compute environments. We proudly shared that the future generations of Ampere servers are expected to feature higher core counts, all the way up to 512 cores, with a high-performance mesh, die-to-die interconnect, improved power efficiency, and 12-channel DDR5, and including integrated AI acceleration. And for you infrastructure folks, this is all intended for an air-cooled environment. To hear more about these, I encourage you to look at recent announcements at amperecomputing.com. So we've talked a little bit about why we're here and the technology we'll be discussing today. We appreciate that as you think about adding a mixed architecture to your support matrix with the complexities of glue code, CI, test, and performance variances, it can be a downright frightening proposition. So let's speak frankly about what's on a lot of people's minds. Migration to different systems can seem daunting in a mixed architecture world, especially with the legacy of years or even decades of x86 software. We acknowledge these concerns. They're all valid, though today we hope to alleviate some of them and perhaps give you a deeper insight and confidence to not only explore, but recognize it's manageable with the right approach and can lead to tremendous benefits. We'll discuss which software will run on ARM64, how challenging the transition might be, and the support available to make this process smoother. Now, understanding the migration path and leveraging available resources can make this shift a strategic advantage rather than a hurdle. And know that this isn't just an infomercial talking about the successes. It's not all easy and simple, though we're hopeful that these conversations today will illustrate the fact that it may be easier than you think and the benefits are compelling. So let's unpack these just a bit and give a few pointers. First, the software ecosystem support is both comprehensive and growing. This is but a sampling of the offerings. We've put tremendous rigor in the last 5 years, really to change the conversation from what's going to run on that to, well, what won't run. There are robust solutions to be found in your favorite marketplace or repo across a variety of needs. For example, databases. Databases are a first-class citizen on Ampere. Popular databases not only function, but are optimized more and more, including things like Oracle DB, ScyllaDB, and Cassandra. DevOps and AI tools and workflows are evolving. We're excited to see advancements with things like GitHub supporting ARM-based runners, plus modern AI offerings like PyTorch and Wallaroo, adapting to leverage Ampere's processing capabilities. The orchestration and virtualization category has been growing tremendously. Modern tools like Kubernetes, OpenStack, and Stackable are facilitating Ampere support. The good news is, if you're building a containerized application, almost all major container-based images, including Docker images, are already compatible. So if you're building your containers either natively or emulated, you'll find those are already available. Popular configuration and monitoring tools like Terraform and Datadog, and many, many more are available. And finally, operating systems and languages. All of the tools and software you've come to rely on in your development. Most major Linux distros, including OS-based images like Ubuntu, SUSE, Oracle Linux, and RHEL, all have ARM64 versions, and the number of optimizations and improvements in the kernels and the tool chains has been growing at a steady pace. As you hear from our other presenters today, they'll delve further into details about the specific stacks being used in their experiences. But let's talk a little bit about making the change itself. We've been hard at work improving the developer experience for these migrations. So as you think about your software strategy, consider this framework to expand your knowledge of mixed architecture environments. Let's unpack this a little bit and share more about the assets at your disposal. First, with learning. We start with understanding the hardware architecture and its relevancy, the software dependencies you may have, and the expected benefits. So in order to explain this a little deeper, we've created the Ampere Developer Center. Here we've got hundreds of technical documents, samples, tools, and developer-curated resources all in one place. We've extended that information to our Developer Impact YouTube series, providing quick hits with industry colleagues. And you can stay informed with the latest announcements, news, and updates via our developer newsletter. And next, you begin assessing your situation of your software landscape. Here you are going to evaluate how your current applications and software systems align with mixed architecture environments. We've created dozens of case studies and detailed how-to tutorials on this point, really using common practices and software to show how porting and optimization can work. We've got a collection of tools and docs collectively called the Ampere Porting Advisor that can bootstrap your efforts. And we've been rigorously running functional regression tests on over 150 software packages and reporting results from multiple product generations. I'll share more on the last two items in a few slides. So as you're ready to experiment, we start to look at the build resources. We believe in using standard tools and libs. These are the things you know and value, things like Git and GCC, LLVM, and Java. And on the last point, remember that interpreted and compiled bytecode languages are going to run without modification. In support of these evaluations, we've created dozens of workload briefs with performance recipes for running a specific workload or on different cloud service providers and bare metal. And then additionally, we offer workload tuning guides with step-by-step instructions to implement porting and tuning recipes. And after that, you're ready to test and optimize. We favor using common CI/CD test and optimization tools. Dave Neary will speak in more detail about these in his session. As the number of devs modernizing their software has grown, so too has the Ampere developer community. We've got hundreds of active participants and thousands of monthly views sharing experiences on these points. We've also spun up getting started guides and pointers to hardware access at multiple CSPs, many of whom have generous trial offerings. And we're announcing the availability of a new tool today. It's called the Ampere Performance Toolkit, which will aid in consistency and ease of performance benchmarking. And on this, I'll share more in a couple of slides. And should all go well, you're ready to deploy. So Ampere is a rich collection of channels to access production hardware. We've moved from all the behind the scenes work to getting deployed in big infrastructure and making these products available in the cloud, on-prem, in your office, or in your lab, including instances at 14 cloud service providers globally, at places like Oracle, Microsoft, Google, Equinix, Hetzner. We've got 16 integrators and solutions providers ready to help you integrate and deliver solutions, including Avantech, Boston, and DTI. We've got 15 different systems providers and dozens of SKUs for a variety of form factors, including from Supermicro, HPE, Gigabyte, IEIT. And we've got 4 different redistributors, including from Arrow and Newegg. And out of all of these assets, I wanted to call out 3 resources that may be particularly useful. First, Ampere Ready software. We've been running and publishing a spectrum of 150 packages regularly for generations of Ampere products, just to confirm functionality. Second, the Ampere Porting Advisor. We've created a collection of tools and methods that provide guidance on transitioning your applications to Ampere, accelerating ports and improving confidence in heterogeneous deployments. And third, today we're announcing the open source availability of the Ampere Performance Toolkit. Now, this is a benchmarking framework that assists in evaluating performance metrics in a consistent, predictable way across different platforms. Now, with that backdrop, let's talk about how we'd like to use our time together today. Now, we're bringing together software contemporaries in sessions that model the journey that developers have when considering an architectural migration. It's really about the why, the what, and the how. We want to expose you to some of the challenges, breakthroughs, and benefits of porting to Ampere-based compute. And we don't expect to have all the answers. We're hoping to hear some tough questions and lively interaction. And that's okay. We're adventuring together. So let me walk you through what you'll hear today and who you'll hear it from. First, we'll talk about the why. Sean, Dor, and Kate will have a lively discussion around why cloud-native software matched with Ampere's hardware designs delivers compelling benefits in performance and sustainability. So you'll hear from ScyllaDB and Fermyon about their experiences, challenges, and breakthroughs. Once we talk through the why, let's entertain some of the what. Naren will speak with experts from Uber and Oracle about what they think about when making architectural choices. Vikrant and Dimitri will share considerations when designing, migrating, and deploying services at scale to maintain cost discipline and elastic scalability, and share insights on the customer and economic benefits. Now, of course, all of these software and services are using AI constructs today. So we've got to discuss how to put AI into production. Just rapid advancements in generative AI and the adoption of machine learning throughout software stacks has really captured the attention of developers. And yet many data science projects never make it to production, and those that do often waste hardware and engineering. So in this session, Victor, Steve, and Amar will explore how Ampere processors can optimize cost, performance, and improve onboarding for your learning models and reduce the cost of running AI inference workloads in the cloud. And it's not just AI that's captured developers' attention. Let's face it, we live in a mixed architecture world today. The heterogeneity of computing resources in the data center has expanded. Adding a new architecture means rebuilding and testing your software on that architecture, packaging it for your customers, and managing daily operations in production. So Dave, Andreas, and Maxi will share practical examples on how they've dealt with continuous integration, testing, and packaging from their experiences making product available to customers for Ampere and x86. As you can see, it's an exciting lineup of experts and experience, so let's get going. First of all, thank you for joining us today. Your presence is a testament to your commitment to learning. Maybe a few procedural notes as we get going. We're trying a virtual platform, and we'll be using different rooms for each session. We look forward to your participation in the sessions via chat and QA. We're here for you. Though even more importantly, we want to hear from you. Live experts from the technical staffs are available throughout. We'll hold a virtual networking session at the end where we hope to have an interactive and vibrant conversation. Though please try to keep the question stream relevant to the current topic. We'll record and post the material for post-event sharing. And finally, we hope you find these sessions valuable as you prepare your cloud compute strategy. So really, just like those ancient Greeks, we're exploring new worlds together. So thank you, and please join Sean Varley for the first session starting in a few minutes.